Welcome back to Zero Dark Emissions. Last time we left off with the installation of the main battery box, and in this episode we will start the installation of the secondary battery box, which also contains our EV control equipment. The control equipment itself will be handled in the next episode, but the box construction will take this equipment into account. The first thing we need for the secondary battery control box is a support platform for it to sit on, which we touched on when we installed the front motor, since this platform shares support bolts with the front motor mounts. The platform will be supported at the front end with short supports welded to the platform that connect to the existing bolts at the chassis, and at the rear with taller supports, which are the ones that share mounting bolts with the front motor mounts, and it is for this reason that this platform was actually fabricated before the front motor was installed. The rear supports are bolted to the platform. I'm starting here with tacking the front supports to the platform. After removing the platform, I can fully weld these supports. The next thing is to weld support ribs at the underside of the platform. These ribs provide adequate strength and stiffness for support of the batteries. You can see that for two of the ribs I have drilled holes which will be used to support the actuator for the front drive disconnect. With the ribs installed, we need to drill a number of holes in conjunction with welding on nuts for various items that need to be bolted to the platform. We've already drilled mounting holes for the inverter platform that will support the upper inverter for the rear motor, and now we're handling the mounting holes for the lower inverter for the front motor. The next thing here are the mounting holes for the front of the secondary battery control box. There are 3 clip angles that will be welded to the front of the secondary box that will bolt down to the platform here. Now we can weld the nuts that are associated with these mounting points. Here you can see where I decided to take the platform down lower than originally planned in order to ensure that I do not have any issues with clearance at the hood. I am drilling mounting holes here, and these also get welded nuts for the bolts that will attach to these supports. The supports themselves now need to be cut down, and for that we'll head back over to Bears fan Rob for him to cut these down with his plasma cutter. With the supports painted and installed as part of the front motor installation, which you can see in episode 11, and with the platform itself painted, we can get the platform installed. The secondary battery control box follows the same basic logic as the main box, with some key differences. First, since the box does not need to sit within the chassis rails, and because it needs some additional space to make connections between the inverters and the control equipment, it is slightly wider than the main box. This also allows us to move the mating surfaces of the clamshell lower so that we have slightly better access at the lower cooling manifold. Second, since this box is supported by our new platform, we do not need the trusses between modules as we have in the main box. Also, because we have to fit in control equipment, we need the box to extend in length beyond what is needed for just the batteries. However, we do not have enough space to just simply elongate the same width and height for the batteries, since this extended area will need to creep into the doghouse area. So the extension is lower in height, holding at the bottom, and narrower in width, holding at the passenger side, which allows it to enter into the doghouse opening at the firewall. This complicates the geometry of the box construction such that we have to weld together some odd components to make it all work. You can also see here at the front of the control side of the box where we have the openings for several power and control receptacles, and these will be laser cut. We will get into all of these connections in the next episode. We'll start here at the simpler end of the box, which is basically the same as the main battery box, except that we only have one bump out at the cooling side. We don't need it at the high voltage side, since the additional box width gives us room for electrical connections at this side. Now we'll move to the control side, which is a little more complex as mentioned. Here you can see all of the plug openings which have been laser cut. The one opening that I did not have laser cut is for the plug for the high voltage line that will be coming from the positive end of the battery box. That's the connection coming from the rear of the main box. And I left this out since I was a little undecided about where to place this. I'll get into that later. Now here you can see this little L-shaped piece that we need to attach. This provides for a mating surface for the top due to the complicated geometry in this area. The piece behind the L is just temporary to provide the correct location of the L, which is set back from the front edge by the 1/8 inch thickness of the top. Now we have the top temporarily placed along with the plate that transitions from the battery portion of the box to the control portion of the box. This plate will now be welded to the main portion of the top. You can see here where the top slides over the L that we just installed. As on the main box, we can now cut the openings for the access ports, which were left on so as not to warp the bends, and also, in the case of this control box opening, to keep the components square and true prior to welding onto the larger box top. Next we will drill and tap the holes for the fasteners that mate the bottom and top together, as well as for the access port covers. Here you can see the clips that attach the box to the platform. These are bolted down to the welded nuts that we installed when we constructed the platform and will now be welded to the box. As with the main box, we can now apply liquid rubber at the high voltage areas and to the box seams. You can see here where I am bonding the rubber sheet to the box with the liquid rubber, since the high voltage bus bars will not be held tight to this as with the main box. However, the liquid rubber will not provide a good long-term bond to the rubber sheet, so I followed this up later with a line along the top with cyanoacrylate glue, otherwise known as crazy glue, which is about the only thing that provides a good rubber-to-rubber bond. As with the main box, the secondary box also needs the corrugated plastic sheet at the bottom in order to create space for the battery fins. However, since we do not have trusses separating the battery modules, we can handle this as a single continuous sheet rather than individual sheets at each module. We also need to provide some holes and notches for the high voltage, low voltage, and coolant glands for lines that enter from the bottom. Next, we will install an added piece of corrugated sheet for the remaining control box portion of the box. This piece needed to be fabricated in order to accept the shelf, along with its associated attachment clip that is needed for our control equipment, which we will cover further in the next episode. The glands being installed here are for the 2 pairs of 50mm wire that extend from our control box to the inverters. And here are the ones for the cooling lines at the front of the box, which will go out to the radiator and cooling pump. As well as the ones at the front of the box coming from the main box. We also have the 2 at the bottom of the box for the high voltage line and low voltage conduit coming from the main box. Now we can finally get the batteries installed, which basically follows the same procedure as the main box. Note that we can use the stock Vero battery board harnesses without having to extend their length, since we have additional room at this box. The only modified harness is at this first one, since it needs to extend to the connection at the battery coming from the main box at one of the whips, as well as to the BMS for the other whip. And this also has a different bus bar at the bottom connection to bring our connection point up toward the top. This last module has a different connection at the top, which will now allow us to make the high voltage connection between the first and last batteries in the two boxes routed through the cable glands. I have already cut this 95mm cable to length and crimped the lugs to each end. Now we will install the conduit for the low voltage connections. Since the bends are a little tight, I am heating this up with a heat gun to make it a little more pliable. The last thing is installing the cooling lines, and this is basically the same as what we did at the main box. As before, we tested the pressure for the combined main and secondary box cooling lines, and the pressure held overnight. Okay, so that's it for now. Next time we will install the control box equipment, including the BMS, contactors, fuses, pre-charge relay and resistor, and more. See you next time.